Hello, everybody. So in this video, I'm going to be discussing confidence intervals for the population mean when the population standard deviation is unknown. So let me go ahead and share my screen and we'll get started here. All right, so we're going to start with when we know the sample statistics. So assume we're trying to estimate the population mean length of wood planks made by a factory. Take a sample of 60 planks and determine the sample mean length is 2.5 feet with a sample standard deviation of 0.1 feet. Find the 95% confidence interval and interpret it in the context of the problem. All right, so let's start with the by hand version here. So this is the formula for the by hand versions. You only have to do this, like I said previously, once on the project. You never have to use this formula when you're computing confidence intervals on the homework, on the quiz, on the test, anywhere. Only one time on the project we use this formula. So to use this formula, so we have the sample mean, this is the sample standard deviation and the sample size. So we have all of those values here. We just need this t value here. So to get the t value, you first need to calculate alpha over 2. So alpha over 2 is 1 minus the confidence level all divided by 2. So in this case, it was 95% confidence. So it's going to be 1 minus 0.95 divided by 2. And if you do that out, you will get 0.025. Then, so that's the alpha over 2. So then what we're going to do with that is, so I'm going to go to probability simulation, probability calculator, continuous. I'm going to switch to probability to values. And then this alpha over 2 is going to be the upper tail. But you also need to change this to student t distribution. It's not a z value, it's a t value. So, and then the degrees of freedom, so that's the sample size minus 1. So in this problem, I took a sample of 60 planks, so my degrees of freedom will be 59. And then check graph, hit the eyeball, and I get 2.001. So that's my t value. So then you can plug that in along with the mean, sample standard deviation, and sample size, and you could put that all into the formula and compute it in the calculator. That's all in notes, so I'm not going to show that here, but I did just want to show you how to calculate that t value. And now, so to actually do it in our Rguroo, how we're going to be doing it all the time, because like I said, we're only going to use that formula for the project. So the rest of the time, we're going to use our Rguroo confidence interval calculators. So analytics, analysis, mean inference, one population. So my sample mean here, so I had a sample mean of 2.5, sample standard deviation 0.1, sample size 60. So 2.5, sample standard deviation 0.1, sample size 60. And then you need to put whatever the variable name is in here. So it's plank length in feet. I always include the units in my variable name. You could put anything in this box in reality, but I always put the variable name in there with whatever the units are for that variable name if applicable. So my confidence level is 95%. And then it is going to be a t statistic because I don't know the population standard deviation. So if you don't know the population standard deviation, it's t statistic. If you do know the population standard deviation, then it's z statistic. Hit the eyeball. And then I'm going to get my confidence levels, the lower CL and the upper CL. But let me tell you about some of the stuff it gives you here. So the standard error. So in our formula, this is called the critical value. This is called the standard error, and then multiplied together. So this whole thing here is the margin of error. So it gives you the standard error and the margin of error, just for your reference purposes. You probably won't need them, but it does give them to you. So then if I'm going to write my confidence interval here, so in proper confidence interval notation, so that's going to be 2.47 and 2.53. So you're going to write it in proper confidence interval notation in parentheses first, and then you're going to give me the interpretation sentence on a quiz or a test. So going back to my PowerPoint here. So we are 95% confident that the population mean population mean length of the wood planks made by the factory is between 2.4742 feet and 2.5258 feet, which is the same numbers that we had here. So we are 95% confident, or whatever percent confident, that the population mean, whatever the context of the problem is between the two values of the confidence interval with units. Don't forget the units here. All right, so let's do another one like that. So assume we are trying to estimate the population mean speed of pitches by a particular MLB pitcher. Assume we take a sample of 100 pitches and determine the sample mean speed is 92 miles an hour, sample standard deviation of 5.2 miles per hour, find the 90% confidence interval, and interpret it in the context of the problem. So let's talk about the by hand version first. So as with the last problem, we have the sample mean, sample standard deviation, and sample size. We just need the t-value to do the by hand version. So it's 90% confidence. So I'm going to change this here to 0.9. Then if you do the math out there, that'll get you 0.05. Close that out here and open the probability tab. So what should we have? Too many dots here. Hold on. There we go. All right, so then we're going to go under probability calculator, continuous, change it to probability values, change the distribution to student T, and then this alpha over 2 is going to be the upper tail. And then my degrees of freedom is the sample size minus 1. So 100 minus 1 is 99. So I have 99 degrees of freedom. Check graph, hit the eyeball. I get 1.66. So that's going to be the t-value. So you can plug that in here with all the other information. That's all shown in the notes. Like I said, I just want to show you how to calculate the t-value. And also, like I said, you only have to do that with the formula on the project. That's the only time you have to do it. The rest of the time, you can use the Rguroo confidence interval calculator. All right, so using that calculator, so analytics, analysis, mean inference, one population. So my sample mean here, so I had a sample mean of 92, sample size of 100, sample standard deviation of 5.2. So sample mean 92, sample standard deviation 5.2, sample size 100. My variable here was pitch speed, so pitch speed miles per hour. Like I said, you could put anything in this box, but I always put the variable name with units. Confidence level is 90%. And then it's t statistic because we don't know the population standard deviation. If you did know the population standard deviation, it would be z statistic. Hit the eyeball, my lower CL and upper CL make up my confidence interval. So writing that in proper confidence interval notation will get me 91.14, comma, 92.86. So you have to write it like this first for me on a test, and then you have to give me the interpretation sentence. So my interpretation sentence here will be, so we are 90% confident the population mean speed of pitches by a particular MLB pitcher is between 91.137 miles per hour and 92.863 miles per hour, which is what we have here. And so we are whatever percent confident that the population mean whatever is between the two values in the confidence interval with units. Okay, so let's do a couple with data sets now. So this one we're trying to estimate the population mean number of hours spent doing homework on a daily basis by students at a school. We took a sample of 17 students and we have the data here. We want the 98% confidence interval and then we're going to interpret it. Okay, so let's start by doing the by hand version here. So notice I'm not really given anything but the sample size here. So I just have the sample size of 17. I need the sample mean, I need my sample standard deviation also. And I need the t-value. So let's get the t-value first. So calculate the alpha over 2. So it's going to be 1 minus 0.98 divided by 2, which is going to come out to be 0.01. And then probability simulation, probability calculator continuous. Yeah, and then probability values, change it to student T. So my degrees of freedom, so I had 14 data values. So 17 data values, excuse me. So 17 minus 1 is 16 for my degrees of freedom. Then my upper tail is 0.01. Check graph. Hit the eyeball. And so 2.583 would be the t-value that you would plug in here in the formula. And then to get the mean and sample standard deviation, let's download the data set from Blackboard. So it's the hours doing homework. And then I'm going to go under, so I need to import it. So data import the data set. Choose the file here from my downloads folder. So remember you put a header in the first line if there is a title in the first line, which all of my data sets have titles in the first line, and the ones on Newton should, but just double check it. If it didn't, you would put no header, but it should have a title in the first line. Hit upload. There we go. And also, so when you open the data set, so if you double click on the data set and you open it, then you can also see if you didn't have the sample size, the total rows would give you the sample size here. And then, but I also go over that in the project video, which is the only time you're doing it by hand anyway. So I also go over how to find the sample size in that video. So analytics, analysis, numerical summaries. Select my data set, move the variable over, and then I need the mean and the sample standard deviation. Hit the eyeball. And so the mean is going to be the X bar here, and then the sample standard deviation would be the S. Plugging that in along with the t-value and the sample size, and you can get your answer by hand. And that, like I said, the rest of the setup and the calculation for that is in the notes. I just want to show you the Rguroo part on here. And you're only, like I said, have to do that one time on the project. The rest of the time, you're going to compute your confidence intervals on the Rguroo confidence interval calculators. All right, so let's now compute the actual confidence interval on Rguroo here. So analytics, analysis, mean inference, one population. Select my data set and my variable. I don't have a population standard deviation, so I have nothing to fill in there. Confidence level is 0.98. And then since we don't know the population standard deviation, it's t statistic. If you knew the population standard deviation, it would be z. Hit the eyeball. So my confidence interval, improper confidence interval notation will be parentheses 1.999 and 3.548. So lower CL and upper CL. So you'll write it like this on a quiz or a test first, and then you give me the interpretation. So the interpretation, so we are 98% confident that the population mean number of hours spent doing homework on a daily basis by students at a particular high school is between 1.99 hours and 3.548 hours. So we are whatever percent confident that the population mean, whatever the context is between the two bounds of my confidence interval with units. Don't forget the units. All right, so let's do one more problem. So we're trying to estimate the population mean wingspan of players in the NBA. Assume the wingspans are normally distributed. We sample 15 players and their wingspans in feet are the following. Find the 85% confidence interval and interpret it in the context of the problem. All right, so let's first do the by hand version. So we need the t-value, the sample mean, and the sample standard deviation. So let's start with the t-value. So this is going to be 1 minus, so it's 85% confidence. So it's going to be 1 minus 0.85. Wow. 1 divided by 2 is going to come out to be 0.075. And then going under, probability simulation, probability calculator continuous. I'm going to switch the probability to values and then change the distribution to student T. So I believe there was 15 data values. Yep. So my degree of freedom is one less than that, so 14. And then the alpha over 2 is the upper tail. Check graph, hit the eyeball. So 1.523 will be the T value that I would use in this formula. And then now I just need the sample mean and the sample standard deviation. So let me download the data set off of Blackboard. Data import data set. Choose the file from my downloads folder. There is a header on the first line. My data sets always have a title on the first line. Just double check on the Newton ones that they do, but they should. Hit upload. There's our data set. Once again, when you have the data set open, when you click on it over here and open it, you can see that there's 15 data values if that wasn't given to you for the sample size. Okay, and then to get the mean and standard deviation, analytics, analysis, numerical summaries, select the data set, select the variable, go to univariate, check mean and sample standard deviation, and hit the eyeball. So the 6.473333 would be the X bar here, and then the 0.5519, etc. That would be the S here. And then plugging in that with the T value and the sample mean, you can get your by hand confidence interval. The rest of that and the setup, the full setup with the answer and stuff, that's all in the notes. So like I said, I'm just showing you the Rguroo part. And you only have to do this once again by hand once for the project. That is it. The rest of the time you'll use the Rguroo confidence interval calculator. All right, so doing it in Rguroo now. So analytics, analysis, mean inference, one population. Select my data set and my variable. Don't have a population standard deviation, so leave that blank. Confidence level 0.85. And since we don't have the population standard deviation, it's T statistic. If you did have it, it would be Z statistic. Hit the eyeball, and I get, so, and also just a side note, if you wanted to save it, you could put a title here and hit save as. But writing it in proper confidence interval notation in parentheses, so 6.256, comma, 6.690. So you will write in parentheses lower CL, comma, upper CL first, and then you're going to give me the interpretation sentence on a quiz or a test. All right, and then back to my little PowerPoint here. So we are 85% confident that the population mean wingspan of players in the NBA is between 6.2563 feet and 6.6904 feet. So we're whatever percent confident the population mean, whatever the context is between the two bounds of our confidence interval. And then I want to show you guys one last thing here before we wrap it up, just as a quick little reminder. So I'm going to show you on the Newton homework here. All right, so just showing you an example here. So on the Newton homework, just as a reminder to download a data set, if it gives you a data set, you just click on the download CSV button, and then you proceed from there with the rest of the steps, putting it into the Rguroo confidence interval calculator. And that is it. So that is confidence intervals for the population mean when the population standard deviation is unknown. If you have any questions, please feel free to reach out.